One.
Morning, afternoon, or evening, depending on when you're watching, guys. So this is day 5 of our calculus, unit number 4 now. So we're getting there. This is a short unit. We're on the 5th day. We'll probably have maybe another instruction day or two, and then it'll be a hand-in. I really haven't decided whether I'll do a quiz yet or not, but we might do a really quick, small quiz as well. And what we're going to do today is taking the first and second derivative tests and using those two things together, along with some of the other information that we have, uh, to graph a polynomial graph. Okay, and as you noticed, when you looked at last day's practice, I said don't do the last two that were rational functions. Okay, we'll do an example of that later on, probably the next day, on graphing with putting a polynomial and a rational together. But those are things that we used limits for way back in the day to get the asymptotes. Okay, so now that our board's up here, let's go ahead and set up our outline that we're going to do today. What's our goal here for today? Well, we have a pretty simple goal on day 5. Oops, wrong spot there. This is day 5, unit 4. Okay, and what we're looking at today in calculus is we're going to be looking at using the second or first and second derivative tests to graph a polynomial curve fully. Okay, so if you remember back in math foundation or math pre-cal 30, when you did polynomial graphing, you noticed that you had to use whether it was an odd or even function and all that kind of stuff, and how many intercepts it had and all that kind of stuff. That's still useful, and we can still use that. But calculus will make it much easier for us because calculus will tell us where the maximum and minimums are, where the inflection point is or are, where they are, and we'll be able to sketch a rough sketch of the graph, no problem. And that's what we're going to do today. And we're going to do a fairly complex example. So let me, on my other side here, let me pull up my example that I want to do. And let's see if I can find it here. Derivative polynomial curves. Right here. Okay, I'm just waiting for it to pop open. Okay, so what we're going to do here is we're going to kind of have a little bit of a strategy here. Okay, so what we got to do is we got to find the critical numbers. Okay, find the critical points. Okay, find the max and min values. Okay, or if you want, you could say intervals of increase, decrease. Oh, I can't type here today. Okay, and we also have to find the inflection point. Okay, there's any inflection points in there as well, and then we can basically we'll sketch it from using those ideas. Okay, so what we're going to do here is pretty simple. So let's have a complex example to use. Okay, so let's say our curve that we're going to sketch is going to be, and we're not going to specifically graph this. We're going to use it as a sketch. So y prime, or y prime, whoops, y just, derivative comes next. Let's make it skinnier here. Y equals, let's go 3x to the 5th minus 10x cubed. Okay, that's a really nasty one. It can have as many as 5 intercepts. It can have as many as 4 turning points or inflection points. So it can be quite involved. So the first thing that we're going to do is going to do the first derivative test. The first derivative test gets us our critical points. So let's find the critical points within this particular equation. Okay, so critical points first. I like to label it critical points so I know what I'm doing. So y prime equals 15x to the fourth minus 30x squared. Okay, well, we have to kind of get the critical points, so we have to solve for x here when we put y prime to 0. Okay, so what we can do is we can take out a common factor first. So if we take out a common factor of 15x squared, then we have x squared minus 2. Okay, this is a difference of squares. So this is going to be 15x squared times x minus root 2 times x plus root 2. Okay, so that gives us 3 critical points that we can use on our graph. Okay, so x can equal, well, maybe I'll have to do these one at a time here so I don't throw you guys off here. So first of all, each of these can equal 0. This can equal 0, this can equal 0, this can equal 0. Okay, so 15x squared equals 0. Okay, divide by 15 on both sides, x squared equals 0. So x can equal 0. Okay, so this is critical point 1. So if we put a 0 in here, it's going to be 0, 0. So crit point 1 is 0, 0. Got that one. That's the easy one to do. The next one is, if we put this equal to 0, then x would equal root 2. Okay, if you move the root 2 over. So if x is root 2, we have to find out what y is. So if we go y equals 3 times root 2 to the 5th power minus 10 times root 2 to the 3rd power. Okay, now you might be like, ooh, how do we do powers of 5? Okay, root 2 times root 2 times root 2 to the power of 5, and what does that all mean? Well, you can do that, or you could change it to decimals if you want. It doesn't really matter how you do it, but if you remember what this really is, it's actually not that hard to do, like root 2 to the power of 5. Okay, this is like saying root 2 is like saying 2 to the power of 1/2. So this is power of 1/2, so this is going to end up being 2 to the power of 1/2 times 5. So 2 to the power of 5 over 2, if you write it as exponents. Okay, so you can work it out that way. Or you can just take your calculator, if your calculator works in roots, and work it out that way as well. So if we go root 2, clear here. Oops. Square root 2. Okay, we get about 1.41. So if we want to do an approximation, we can do it that way using decimals. So 1.41 to the power of 5 times 3. Okay, so we'll go, that's 16.7. So we'll do an approximation. Okay, minus 1.41 times to the power of 3 times 10. So it's about negative 28.0. So we're getting approximation here of 16.7 minus 28, I guess I could 11.3 negative if you want to do decimals. If you wanted to do roots and stuff, you could have done that as well. But since we're doing a sketch, we'll just do an approximation. So let's do critical point. This is critical point 2. So critical point 2 is root 2 or 1.41 and negative 11.3. Okay. If you worked it out with roots, it ends up being root 2 and negative 8 root 2. Okay. Okay, so then we do critical point 3, which will be very similar. It'll be negative root 2. So critical point 3. Okay, there's 2. So we're going to go y equals 3 times negative 1.41 to the power of 5 minus 10 times negative 1.41 to the power of 3. Okay, so if we take our calculators out, we're going to get a result for that as well. So 1.41 to the power of 5 negative gives us a negative 5.57 times 3. So this is going to be our negative 16.7 plus, in this case, should be the same thing. It's better double check because you know me, sometimes I make errors, times 10. So that'd be negative times negative 10. So that's 28. Okay, so this ends up being negative 1.41 and positive 11.3. So there's our critical point number 3. So we can tell what the max and min values are just by looking at these critical points. We probably don't need to do the test or the sign analysis part, but we could if we wanted to double check ourselves. Okay, so we did that. We've got our critical points. So now we're going to do our second derivative test. Okay, let me just move my notes up a little bit so I can follow them a little bit. Okay, so now we want to check to see for inflection points. Okay, so let's move that up a little bit. So I get 3 critical points. Let's check for max and min first. So we should see, if we're looking at the points, that should be a min, that should be a max, and this could be a max or min depending on, because it's a 0, it's a kind of in between those two, right? So let's do second derivative test, y prime prime. This will give us our inflection point. Okay, so if we're doing y prime prime, we have to say we got 15x to the 4th minus 30x squared, so that should be 60 x cubed minus 60x. Okay. Okay. Now, if we want to check to see which of these are max and mins, if we put in 0 here, we get 0, so it's not a max or min. So this one will not be a max or min. It's probably going to end up being an inflection point, because if we remember, if you plug in your value for x in the second derivative, if you get a negative number, it's a maximum. If you get a positive number, it's a minimum. So if we put in 1.4 here for one of our critical numbers, for this number, 1.4, and then this one, it's going to be a positive number. So this is going to be a min, which makes sense because that's negative. If we put a negative number in there, it's going to be a positive, it's going to be another negative number. So that makes sense that it's going to be a maximum being negative, right? So that's just a little double check that we can do. But we can also set this to 0 to get our inflection point. So this is going to be 60x times x squared minus 1. Okay, so this means we've got 60x times x minus 1 times x plus 1. So look at the amount of inflection points that we have. We have 3 inflection points. We have an IP at x equals 0, or x equal positive 1, or x equal negative 1, because of these two, right? So we're solving those to 0. So we have 3 possible inflection points. Okay, so just moving my notes down a little bit here. Okay, so let's check our concavity. Let's check our what our inflection points are. So inflection point 1 is easy to do. Okay, that's going to be 0, 0. Okay, because if we put a 0 in, not here, but if we put a 0 into the original equation, we get that. Now we're going to do inflection point 2, which we're going to put 0, 1 into there and negative 1 into there. So inflection point 2. Okay, we're going to put y equals, I always forget what it is. What was it? 3x to the 5th minus 10x cubed. Okay, we put a 1 in there. We get 3 times 1 minus 10 times 1, because cubed into the 5th. So this would be 3 minus 10, which is minus 7. So our inflection point is 1 and negative 7. And our third inflection point, okay, IP2, IP1, IP3 is negative 1. And, well, let's plug it in. Y equals negative 1 to the 5th minus 10 times negative 1 to the 3rd. So this would be the same as saying negative 3 plus 10, which equals 7. So negative 1 and 7. That's IP3. So now we've got our 3 inflection points. We've got our 3 critical points, 3 inflection points, and our max and our min value. Okay, so now, so we've got all these points in our head. We've got 0, 0. We've got 1.41, negative 11.3. We've got negative 1.41 and 11.3. There's our max and min values. And then we've got these 2 inflection points. Now, in order to draw the graph, we'll want to know what the concavity is. So let's do the concavity test just to help us out. So let's do a concavity test, and then we'll sketch the graph. Sometimes you don't need to check the concavity, but I'm going to, because this one's got lots of inflection points. Okay, so let's check the concavity. So how do you do that? You take y prime prime, which equals 60 at x times x plus 1 times x minus 1. And we check it. So okay, if we're doing that on our number line, okay, we've got 0, negative 1, positive 1. Okay, and then we've got 60x, x plus 1, x minus 1. Okay, x at 0 is plus here. Okay, x plus 1 is 0 here. Negative there, and then this one here 0 right there. Okay, so if we combine all three of these for the product of all those, we'll just do it in a different color here. Positive here, negative here, positive there, negative here. So it's concave down, concave up, concave down, concave up. So that's important when we're sketching the graph. Okay, so now we're going to sketch the graph. So how do we do that? Let's do that on the next page so it's easier to see. Keeping in mind the concavity and the points. All right, so the first thing that we do is we draw our axis. There we are. Okay, the second thing we're going to do is we're going to put our max value and our min value in. Okay, so our max value, okay, our max value was this one right here. Negative 1.41, positive 11.3. Okay, so we'll go back there, put that in. So negative 1.41, it's about there. We'll sketch this in green. And 11.3. So we'll put, that's our max value. Negative 1.41 and 11.3. Okay, that's one max value that we had. So we'll label that max. Okay, and then we had the min value at positive 1.41 and 11.3 negative. So go about an equal distance in our sketch, go about an equal distance down. So we had a min value here. Okay. So now we also had a critical point at 0, 0. Okay. And that was one of our IP points. Okay. Then we had another IP point at negative 1, 7, which was an IP point. So it'll be just over here, somewhere in here. Negative 1 and 7. Now is an IP. Remember, an IP point is where the inflection or the concavity changes. And that's going to be important because you're going to start, instead of drawing, let me make sure instead of drawing concave down, you're going to be going, and then as soon as you hit an IP, you'll switch your pen to drawing concave up from concave down, or you'll switch from drawing concave up to concave down. That's why those are important. And our last IP was 1 and negative 7. So 1 and negative 7 would have been about here. Okay, and we label that as an IP. So now we've got all our points. We got our 3 IPs. Our 3 critical points are in there. 1, 2, 3. We got our max and our min value. So now we know that this is from pre-cal 30. If we go back, we know that this is a power of 5 odd function. So odd function, and it's got a positive leading coefficient, so that we know that it's going to go up like this, have a positive slope. So it's going to start low on the left and finish high on the right for our end behavior. So we know that as well. So that means if we go to our graph, this area here is going to swing up at the end, and this area here is going to swing down at the end. Okay, so let's go back to our concavity and look. So we start way over here at negative infinity. At negative infinity, according to our concavity test, at negative infinity, we should all be concave down until we hit the negative 1 spot. Okay, so concave down until we hit the negative 1 spot. So let's go ahead and draw that on our graph. Oh, I went too far. Sorry, guys. Okay, so I want to be concave down until I hit the negative 1 spot. So I want to be concave down the end behavior here, this one's going to be like this. I don't know how that's going to go. And it's going to be concave down, concave down, concave down, concave down. Okay, then it's telling me that the concavity switches between -1 and 0 to a positive. According to this, we're concave down. It should be concave up now until we get there. And then it'll go concave down. So you're going to have a kind of a little S feel. So let's check that on our concavity. So yes, in fact, if we look here, we're going to go to positive, negative, positive. So we're going to go positive, negative at 0, positive at +1. Okay, so let's draw that. So it's going to kind of go like this. So concave down, concave down, concave down. Okay, now do a little upswing. Now I want to swing up until I hit the -0. So I want to be doing a U shape instead of the end. Swinging up, okay, like that. And then I want to do a little, now I want to swing down in a U shape until I hit the 1. So curving there, until I hit that. Okay, this one's not as smooth. It should have kind of maybe went like that. So I'm going to redraw that just a little smoother in there. Okay, so -1 and 7. Okay, and then that's our inflection point. So I'm curving like this so that I have a little S curve here. There, that's a little better. And then when I get here, I'm curving down, and then I got to curve up again. So now I'm doing a U shape. And then that goes somewhere over there. I don't know what the x-intercept. So that's what it goes. Okay, goes like this. Concave down, hit the max, flip over, concave down, concave down, concave down, concave down. Okay, flip your draw, concave up, concave up, concave up, making a U. Hit this one, oh, making an N again, making an N, concave down, hit this one, oh, concave up, finish. And that's how you do your sketch. Okay? Okay, so now you should be able to go back in last day's practice, and do a couple of the sketches. Now you can do one or two from last day's practice where you were just doing all that. So now that you know all those on P's, so now you should go back and you should be able to draw the sketches of those 4 from last day of those curves. So you should be able to put all of our skills together and get this. Okay, before we do that, let's do a little quick Desmos check and see how our sketch matches up. So this is always a nice thing about technology. We can just hit up Desmos. Okay. And plugging in our graph and seeing if it matches up with ours. So let me bring over Desmos here. Okay, and we had y equals, what was it now? I can't remember. 3x to the 5th. Minus 30x, or minus 10x to the 3rd. Oh, that's a number. 3rd. All right, so here's our graph. So if I zoom this out, okay, and we'll bring it over here a little bit. Okay, so according to us, we had an inflection point. So it looks pretty close to what we had. Okay, ours was a little more, we should have been maybe a little more sharp here on our edges because it crosses here, but we could have figured out where it crossed if we wanted to. Okay, so here we have that 0, 0 inflection point. That looks good. If we look up here to where that maximum is, in fact, it matches up, right? Pretty good. Where's that minimum? Oh, look at that. It matches up pretty good as well. But that minimum as well. Okay, here's an intercept. We could have figured out what this intercept was if we wanted to help ourselves just by doing some substitution. Here's an inflection point, and here we had an inflection point at 1, -7, or +7. That's where the concavity changes right about in here somewhere. That should have been an inflection point there as well, where it's going curving up a little bit. So our graph, okay, we probably this one here we should have probably put way more sharper here, and this one here way more sharper, but that's good for a sketch. Okay, so what you can do then is you can go back to the sheet from last day and do the sketches now. Okay, and that's where we'll stop today with our video. That's about a 30-minute video. We don't want to go too much farther. And if we need more practice with sketching, I will do some more practice with sketching if so required.